Scenario 1 shows us the relationship between variable x, which we can define as a cell phone use, and variable y, which we can define as the car accident. So we can look at individuals who use their cell phone and how that might correlate with the number of car accidents. So the question we want to be able to answer is, what is the correlation between x and y given this joint distribution? Well, if we're going to look at the correlation, let's go ahead and just write out the equation we want to solve. Correlation is represented by rho. This is equal to sigma xy, the covariance, over sigma x and sigma y. Well, what this tells us then is we need to solve other things. We need to solve what sigma x is, sigma y, and then also solve for covariance. So let's start with sigma x. So the variance of x squared is equal to the expected value of x squared minus the mean of x quantity squared. Well, given this, we need to then find these values, and we do so by finding first the marginal distribution of x. And we can do this looking at our table, where this is the probability that x is equal to x. And so we can add these across. And so 0.6, 0.8 plus 0.08 plus 0.02 is 0.7. 0.10 plus 0.12 plus 0.08 is 0.3. And so we can rewrite the marginal distribution of x as the probability that x is equal to x is equal to, there's a 70% probability if x is 0, and a 30% probability if x equals 1. Now, once we have this, now we can go ahead and solve for mu of x. So mu of x is equal to, we had this before, the expected value of x, which is equal to the summation over the range of x, that the probability that x is equal to x times the value of x. And so this will equal, the probability is 0.7 that x is equal to 0, plus a 30% probability that x is equal to 1. Therefore, mu of x is equal to 0.3. Now, when we look at the variance of x, this is equal to the expected value of x squared minus mu of x. And so now we need to find the expected value of x squared is equal to 0.70 times 0 squared plus 0.30 times 1 squared, and this is equal to 0.3. Therefore, the variance of x is going to be sigma squared x will be 0.3 minus 0.3 squared, and this is equal to 0.21. But we don't want to find the variance of x. In our equation, we want, right here, we want just the standard deviation of x. So one more calculation to do, and that is the standard deviation of x is equal to square root of 0.21, which is equal to 0.458. So we did that for x. Now we need to return the favor and go for y. So the probability that y is equal to y, finding the marginal distribution of y, is 0.70, 0.20, and 0.10. So I can write out the marginal distribution of y. Let's put this on the same line here and follow the exact same steps we did before. Is the probability that y is equal to y is equal to what we wrote down just here is there's a 70% probability if y equals 0. There is a 20% probability if y equals 1, and a 10% probability if y equals 2. Bringing it back to the example, what it says is 70% probability that you'll have no accidents, 20% probability you'll have one accident, and a 10% probability you'll have 2. So we can find mu y is equal to the summation of y times the probability that y is equal to y. And so we get 0 times 0.70 plus 1 times 0.20 plus 2 times 0.10. So we add all those together, and we get the mu of y is equal to 0.4. We can then look for the expected value of y squared, and this is equal to 0 squared times 0.70 plus 1 squared times 0.20 plus 2 squared times 0.10. And this is equal to 0.6. Therefore, the variance of y is equal to 0.6 minus 0.4 squared, which is equal to 0.44. And so the square root of that, or the standard deviation of y, is equal to 0.663. Now, zooming out, what we've done is we have calculated both the terms here on the bottom of sigma x and sigma y. Now we need to focus on the top term, or the covariance. So when we think of the covariance of x and y represented by sigma xy, this is equal to the expected value of xy minus mu x times mu y. Now we solve for this part over here on the left, so we have that down, and all we need to solve for now is the expected value of xy. So when we look at these values here, we're going to look at the expected value of xy, which is going to be focused on these internal values there. So the expected value of xy is equal to, we're going to sum over the value of x times the value of y times the probability that x is equal to x and the probability that y is equal to y. And this is going to come from our joint distribution. So this is equal to the value of x times the value of y times that probability. So here's where we'll get is when x is 0 times when y is 0, the probability of that is 0.60, plus when x is 0 and y is 1, that happens with a probability of 0.80, or sorry, reverse that, 0.08, plus when x is 0 and y is 2, that occurs with a probability of 0.02. That's the top row from our table. And notice that those values will all be 0. Plus, when x is 1 and y is 0, that happens with a probability of 0.10. Plus, now we get to the values that have non-zero values. X is 1 times y is 1. That happens with a probability of 0.12. Plus, x is 1 times y is 2. That happens with a probability of 0.08. So I add those up. And what I'll get is 1 times 0.12 plus 2 times 0.08. And this is equal to 0.28. So that is the expected value of xy. Well, now I can plug this into my equation. So the covariance of x and y is equal to the expected value of xy, which is 0.28, minus the average of x, which we found to be 0.3, the average of y, which we found to be 0.4, and then we solve this, and this is now 0.16. And so now we found the key parts of what we're looking for. We found the standard deviation of x, standard deviation of y, and the covariance of x and y. So let's bring that all together now for our final equation to find the correlation, which is the correlation is equal to sigma xy over sigma x sigma y. And so this will equal 0.16 divided by 0.458 times 0.663, and this is equal to 0.527. So the correlation between, oops, that should be an N at the end there, X and Y is equal to 0.527. So they are positively correlated based on that result. And that's how we can take a joint distribution and solve for the correlation between the two random variables.